All right, so now that we have the basics of the area between two curves, let's look at a little more complex example. And when we have a couple of regions. So this problem comes from the 2015 AP Calc AB free response questions. Function f, 1 plus x e to the x squared minus 2x, and function g, x to the fourth, so on and so on. All right, and we're going to look at these on the domain from 0 to 2. So once we plot them, we get these two regions. This is more complex than our last problem, not just because of the shape of the curves, but it's also because we have two area problems. There's different curves on the top in each of these. So we actually have to set up two integrals. Whatever this point here is, we're going to have to go from 0 to it and add another integral from that point to 2. And whatever the curve on the top is minus the curve on the bottom here, and then it would be the vice versa over here. Now, if we look at these, right, I think that the curve G is on top here, so this is going to be G minus F and F minus G. But before we can do that, we have to figure out what A is. So another way to think about where that point, where these two curves cross, is it's where they're equal to each other. So where does F equal G? And another way to say that is where F minus G is 0. So we'll just use the computer to solve this equation quickly. Later on in the course, we'll actually see how we can do this from scratch. But for now, we'll use the machine. All right, and this is essentially that curve, the difference between those two functions. So sure enough, around 1, there is a 0. Now, the function that we'll use for this is called root scalar. The way that it works is you give it a function that you want it to find a 0 of, and you give it a range of values that you think that 0 occurs in. So in this case, what we're saying is we think the 0 occurs somewhere between 0.75 and 1.25. And the function is f minus g. Right, where is that 0? And yeah, this is what we find, 1.03. So it's not 1, it's 1.0328, this big long decimal. Right? And sure enough, that's where that thing crosses 0. Yeah, 1.03. So moving it back to that original problem, that's where we want to divide up those regions. So now we just have to define, because I want to use the computer to evaluate these integrals, I just am going to define functions like we did before for the top minus bottom. So here's this region R, the function G on top minus the function F, and then my function for the region S, which is then F minus G. So we just plug in to the quad. So the first region, area under R, is that function R from 0 to where our root was. And then S is from that root to 2. When you add them together, the total area under R and S is 2.00. You know, and again, this is just this is because we saved the value of that root here. So we could have just the same copied the actual value, used it. This is the same as saying this.